Imagine the atom, a minuscule universe teeming with energy and potential. At its heart lies a dense core called the nucleus, a powerhouse of energy. This nucleus is made up of protons and neutrons tightly bound together. Fission is like splitting a tiny, incredibly dense piece of wood, releasing its stored energy. You hit a heavy atom, like uranium, with a neutron, causing it to become unstable. The uranium atom then splits, releasing a tremendous amount of energy and more neutrons in the process. These newly released neutrons hit other uranium atoms, causing a chain reaction that continues to release energy. Fusion, on the other hand, is like squeezing two tiny droplets of water into one, merging their essence. In this process, light atomic nuclei such as hydrogen isotopes are forced together under immense pressure and heat, overcoming their repulsion. This fusion creates a heavier nucleus, such as helium, and releases even more energy than fission, lighting up the universe. Not all uranium is created equal. The journey from raw uranium ore to a nuclear weapon is complex and requires several intricate steps. Naturally occurring uranium has two main isotopes, uranium-238 and uranium-235. These isotopes have different properties and uses. Only uranium-235 is easily fissionable, making it crucial for both nuclear power and weapons. Enrichment is a process that increases the concentration of uranium-235. This involves separating the isotopes to get a higher percentage of uranium-235. Think of it like sifting through sand to find the shiniest grains. The process is meticulous and requires advanced technology. Creating a nuclear weapon requires bringing together enough enriched uranium or plutonium to reach what's called a critical mass. This is the minimum amount needed to sustain a chain reaction. This is achieved through implosion, a method that ensures the material is compressed uniformly. Imagine squeezing a balloon from all sides simultaneously. This analogy helps to understand how implosion works. In a nuclear weapon, conventional explosives are used to compress the fissile material inward, triggering the chain reaction. This controlled explosion initiates the devastating power of a nuclear blast. Thermonuclear weapons, also known as hydrogen bombs, are even more powerful than fission bombs. They utilize a two-stage design. The first stage is a fission bomb, which creates the extreme temperatures and pressures needed for fusion. This intense heat then triggers the second stage, where hydrogen isotopes fuse together, releasing a colossal amount of energy. These weapons are far more complex to build than fission bombs. They represent a significant leap in destructive power. The development of thermonuclear weapons marked a turning point in human history, ushering in the era of potential global annihilation. The immense power of nuclear weapons demands strict international regulations. These regulations are essential to ensure that such destructive power is kept in check and used responsibly, if at all. The Non-Proliferation Treaty, for example, aims to prevent the spread of these weapons. However, the threat remains, as not all nations are signatories, and enforcement can be challenging. Advances in computer simulations and manufacturing techniques could potentially make it easier to produce nuclear weapons. This technological progress, while beneficial in many fields, poses a significant risk if misused. Understanding the science behind nuclear weapons is crucial for informed decision-making. Education and awareness can empower leaders and citizens alike to advocate for safer policies. The catastrophic consequences of their use cannot be overstated. The devastation left in the wake of a nuclear explosion affects not just the immediate area, but has long-lasting global impacts. As we venture further into the 21st century, the responsibility to prevent nuclear war rests upon us all. Collective action and international cooperation are key to ensuring a safer world. We must strive for a future where the power of the atom is harnessed for good, not for destruction. By investing in renewable energy and peaceful applications of nuclear technology, we can build a more sustainable and secure future for generations to come.